Hi, my algebra students. We're going to be talking about volume today. This is going to be a fairly easy-ish lesson. It's definitely geometry, and I'm not getting into too much geometry with you guys because you're going to be taking it next year. But volume is easy enough that I think we could probably do just fine with this. Here's the deal. Let me give you a couple of examples here. So you see that I have this lovely shape here. It's a cube, right? You know what? This might actually work better if I enlarge this. Oh, there's my face. Oh, man. So I'm going to enlarge it, but I'm also going to like put things over here. Okay. This guy is a cube, right? It's got the base of a square and then it's up. That's my cube. Notice how this guy right here is a corresponding, it's got the base of a cube, right? But it comes to a point. We're going to talk about that. Okay, so then we've got this guy has the base of a triangle. You see, like here's the base, right? Base of a triangle. And then it goes like this, right? Also the base of a triangle, but this one comes to a point. Okay. This has a base of a circle, right? Looks like a can of soup. This has a base of a circle, right? But this comes to a point. Okay, so the point of my story here is, let me scooch this back over, is that these guys are called pyramids because they come to a point, right? Oh, let's try that again. These guys are called pyramids because they come to a point. We will not be talking about those. These guys are called prisms. So get those pyramids out of your head. Now, prisms. Here's the deal with prisms. You have two shapes that are connected by a rectangle. Not just one rectangle, but multiple rectangles, right? So like for example, with that said, okay, so for example, I've got this guy right here. Do you see how it's a circle on one end, a circle on the other end? And it's connected by what will ultimately be a rectangle, okay? But the two circles. This one has a triangle here, right? And then it's connected by rectangles or squares, right? Squares are a form of rectangle. So we've got these guys right here, right? We got this guy, it has square, it has another square, right? But it's connected by rectangles. The reason why I say that is because we sometimes have things like this. This is I always mess these up, pentagon. I gotta go back and look that up. Anyway, I have the book right in my lap. So this one is a pentagon. Yeah, see, I second guess myself. I don't know. So this is a pentagon, right? On that side. Then there's a pentagon on this side, right? On either side, but they're connected by rectangles. Why is that important? Well, because you have the two shapes that are non-rectangle, non-square, right? That's the type of prism that it is. So like this guy has a triangle on both sides, but it's connected by these rectangles, I guess, squares, but I can't really tell. So this is a triangular prism, right? These guys have square and a square. You call it a square prism, but a rectangle is a form of square, so we call it a rectangular prism, right? This guy has 6. Terrible at this. God, worst. Hexagon. Why can't I remember these? So this has 6 on one side, right? You kind of see that? Then on the other side, if you flip it over, 6 here, right? So hexagon, but it's connected by all of these squares or rectangles. This is a hexagonal prism. Why am I telling you all of this? Because these are all prisms, right? The way that you find volume of a prism is you find the area of the base. I wish we could call these circular prisms because that would make way more sense. We don't. We call them cans of soup. No, we call them cylinders. But think of it like a can of soup, right? Anyway, the way that you find volume on prisms is you take the area of the base, whatever friggin' shape that is, and you multiply it by the height. Area of this base right here multiplied by the height. Why is this important? Because you have to know what the base is. Do you see how this is a triangular one, right? Triangular prism. You can't say that this guy right here You can't say that this square is the base. It's not. It has to be one of the triangles, right? So area of the base times the height. Area of the base times the height. Area of the base times the height. So really, you just need to be able to find the area of the base, whether it's a circle, a pentagon, a hexagon, a square, a rectangle, a triangle, any of those, find the area of the base, multiply it by the height. In a lot of these problems that you'll be given, they give you the area of the base. They say, hey, this is this odd shaped 3D thing, right? And the area of the base is like 214 meters squared. What's the volume? You gotta multiply that area times the base, or times the base, I see base and the height. Okay, so let's see about some of these problems. Guys, if you're working on these, I am on page 87, right? And we're talking about volume. So volume, by the way, is like, it's just what we use to fill, right? So area was all the squares across, like carpet, right? Carpet we find in area. Volume is more liquid, things that we put into. So if, for example, this is a square on every side. It's not a square prism, it's called a cube, right? So what the volume is how much goes in here, like how many scoops of rice would fill into here, that would be considered the volume. We recognize that with units cubed. So feet cubed, inches cubed, meters cubed, things like that. You may also see it like fluid ounces, but we're not going to be talking about that. We're going to be talking more about the solid volume, okay? So there's a great, I'm going to go back to this guy. All right, so there, you don't need my giant face in there. So there's a great, on page 87, there's this great explanation of the three things. We've got area, which is the floor, right? Flooring. We have volume, which is how much goes inside, right? And here's our volume, another example of a volume. If I had a cube that I stacked together and I made like this, right? I would have 6 cubes in there. And that's because I take this, we take the area of the base. The area of the base is again 6. Do you see that? Because length times width, right? And we multiply it by the height, and the height is 1. So there would be 6 cubes and the volume is 6. Same base here, right? It's a 3 by 2. Do you see that 2, the 2 there? So that's going to be the area of the base is 6 times the height, which is 3. 6 times 3 is 18. So there are 18 cubes hanging out in that box. All right, so let's talk about some examples. Example 2.1 here. This is a triangular prism. Triangular prism. Oops. Let me pause it for a second. My battery's running out. Hold on. Okay, so the area, this is a triangular prism because there's a rectangle here and there's a rectangle right over here, right? And right here and right here. It's not a rectangular prism because there's a triangle and a triangle. So guys, what you want to do in order to classify your shape, look and see if there are any shapes that are not rectangles or squares, right? That's probably the kind of prism that it is. There's a non-rectangle here, which is a triangle, and then on the bottom there, you can't see it, of course. So it's a triangular prism, and the height is what comes in between here. So if this prism was taken and turned on its side, even though we call that the height, it would still be the height, even though it's going to be going lengthwise. We'll get to some of those problems so you can get an understanding. Okay, so taking a look at this, then that base, that triangle, right? It's always a good idea on your 3D objects to draw out what the base looks like. That way you're telling me, hey, this is what the base is. So I give you partial credit if you get something wrong, right? So this is the base, right? And again, to find the area of a rectangle, we do length times width. To find the area of a triangle, we do length times width, cut that bad boy in half, right? So length times width divided by 2. So to find this area, we're going to take the length, or I guess length times height would probably sound better. Length times height divided by 2. Well, 8 times 4 is 32. Divide that by 2, we get 16. So the area of the space is 16. Now all we have to do is multiply it by the height. So we come up here and we see that the height of it is 6 centimeters. So we take our 18 and we multiply it by that 6, we get or by that 16, I'm sorry, 16 times 6, which would give us 96 centimeters. So let's look at this guy. So there's another prism right here, right? This is a trapezoid, okay? Trapezoid. Now, let's go back to talking about this. So let's just refresh, the area of a base, the area of a rectangle, area equals length times width, right? Length times width. Actually, let me write this out nicely. Area of a rectangle, length times width. It works the same for a square. You could say side cubed or whatever, or I'm sorry, side squared, but you don't need that. Area of a triangle is literally just this guy, but cut in half. So it's length times width, or length times height might be a better idea. Length times height divided by 2. How about we call that length times height? Because then it just will be one thing that you have to memorize. So the area of a trapezoid looks like this guy, right? Now, a trapezoid is really just a rectangle, except let's say that this guy is 4 and this guy is 10, okay? Now, the area of a rectangle is length times width, so I'd multiply this times the height. Let's say the height is 2, okay? The height is gonna be 2. However, do I use the 10 or do I use the 4 as my length across this, right? You can't play favorites here. You gotta find the average of the two. So I can't use 4 and I can't use 10. So what I have to do is take 10 plus 4. And remember, average is add up all the numbers and divide by the number of numbers. So I'm gonna take these two guys and I'm gonna divide it by 2. Equals 14 divided by 2, which would equal 7. So the area of the trapezoid, equals length of one side plus the length of the other side divided by 2 times the height. You take the length of the top, length of the bottom, divide that by 2, add those together, divide by 2, and multiply by the height. So that's going to be the area of a trapezoid. Why is that relevant? Okay, so let's go back to this problem. I'll draw it out here. It looks like this. Actually, this isn't even a trapezoid we could do. No. Let's do this guy here. All right, so this is 4 and this is 10. Well, let's say that we do this. We take this and we're going to cut it in half. We can talk about this guy. So if we do that, this guy is 4, but because this whole length is 10, this is going to be 6, right? And this is 6 because this side is 6, right? So again, to find the area of a rectangle, we multiply this times this, and that gives us 24. So the area of that little square there is 24, right? The area of a triangle is length times height cut in half. Now, there's a trick here. You could do 6 times 6 and get 36, right? Or if you cut one of those numbers in half, you've already done the half bit. So 6 times, and instead of 6, I'm going to cut that in half and make that 3. 6 times 3 would be 18. So what we have is 24 plus 18, and that's going to be 42. Okay, so the area of this base is 42. We're talking meters, 42 meters squared. Let's come back over here. So that's this guy right here. But we're told that the height is 8 meters high, 8 meters high. So we found the area of the base. Now we multiply it times 8 equals, whatever that is, 336 meters cubed, because we're talking about volume, right? All right, so you just find the area of the base, you multiply it by the height. Let's see about this. So there are a couple of other examples in there. You have to be really good about being able to find area. Like for 20.3 on page 88, this guy looks like this. Okay, so we've got this guy, right? And this is actually broken up. It's supposed to be like dashed, right? So we want to find the area of this shape. Well, the area of this, we know, is a rectangle, so that's going to be 30, because I take this times this. Finding the area of a square, if you remember that, of a circle. Area of a circle equals r squared pi. Now you could say pi r squared, that's fine too. I just like to throw my pi at the end, right? So just like dessert, I don't know. So the area of the circle is the radius squared times the pi. Well, we come over here, we have a radius of 3. So 3 squared pi, 9 pi. So the area of this bit is 9 pi, except that's the area of the whole circle. I only have half a circle. I gotta cut this bad boy in half, just like that, okay? So that's gonna give me 4.5 pi. 9 divided by 2 is 4.5 pi. For the purposes of this, I think it's easiest if you do the actual math. So we're gonna do 4.5 times and use the pi button if you have it on your calculator because it gives you a much more accurate answer. So if I do that, 4.5 times pi, I get 14.14. You can usually just go to the hundredth and be just fine. So this bit right here is 14.14, right? Actually, we're gonna round up to the 10th. 10th or 100th is usually good, but I'm just gonna round to the 10th because for the ease of simplicity. So what I have is this chunk right here, 30, plus this chunk right here, which is 14.1.144. 44.1 is the area of this whole thing. Now we gotta go back to look at the book, and it says it's 10 kilometers high. So we take this, we multiply it because it's the area of the base, and we multiply it by the height, which is 10 kilometers. And we get 441 kilometers cubed because we are talking about volume, okay? So really you have to have your area totally on lockdown. You need to know how to do these. If you've been struggling with that, if you find that you're getting those problems wrong consistently, you need to speak up because it's just gonna impact your ability to do volume. All right, so for example, 20.4 is a can of soup, right? Cylinder, should probably use the proper name. Again, find the area of the base, multiply it by the height. And the base in this case are those two circles, right? So it is a circle with a radius of 6, and then the cylinder itself is 11. Okay, so to find the area of a circle, we take the radius squared and multiply that by pi. Radius squared by pi. So that's going to be 36 because the radius is 6, and if I do 6 squared and multiply that by pi, I get 36 pi. Okay, 36 pi. Now what I have to do is multiply that by the height. In this case, because it's just a cylinder, you don't have to multiply by pi. You can leave it in terms of pi. So I'm gonna take this and I'm gonna multiply that by 11. Guys, if you've ever seen this trick for 11, 36 times 11 is, take the 3 and the 6 and go like that. 3 plus 6 would be 9, so that goes in the middle. So 396. All right, so the the volume, because this is the area of the base times the height, gives us a volume of 396 inches cubed. 396 inches cubed. So make sure that you're remembering your area of the base, how to find the area of the base. Okay, so guys, let's do this. What I'd like you to do is go ahead and pause the video. The practice problems start on page 89. Down at the bottom it says A. The base of the right solid is 10 inches high. 10 inches high is shown. Find the volume of the solid. So again, you're going to find the area of the base times it by the height. Notice that there's a circle in that base, so you need to find the area of that, but you need to cut it in half. Go ahead and pause the video and see if you can do that. When you're done, come on back. All right, so the base looks like this. That was it was like a portion of a circle. All right, so the radius is 2. You can't really see that. 4 and 10. Well, the rectangle's pretty easy, right? We're gonna take that, we're gonna multiply. 4 times 10 gives us 40. Now we gotta find the area of the circle, and in order to do that, area of the circle equals the radius squared times pi. 2 squared is 4 pi. And then since this is a composite figure and not just something more than a circle is what I mean by that, we're gonna go ahead and do 4 times pi. So 4 times, and remember to use your pi button, we get 12.56. So I'm going to do 12.6, right? So the area of the circle, but, oh, I almost forgot. We got to cut that in half. I reminded you guys to do it and almost forgot. We're cutting it in half because there's only half a circle. So divided by 2 equals 6.3. Okay, so we have 40 plus 6.3 equals 46.3. Let's see what the units are. Inches squared. So we found the area of the shape, right? Or the base, I should say. The area of the base is 46.3 inches squared. So guys, it's really important that you show your work on this, because if you get the area of the base right and then just mess up on the height, I can see where you're going wrong. Now we got to take that, we've got to multiply it by the height, which is 10, equals 463 inches cubed. That should be your answer, 463 inches cubed. If you're off by a couple of digits because of decimal rounding, that's totally fine. I just want you to be within that ballpark. Okay, so for B, let's talk about B. A right circular cylinder has a radius. All right, we've got a cylinder this time, and this time the cylinder's on its side. So when we talk about height, we're still talking about height, but it's on its side, it's laying down. So again, we have to find the area of the base. Area of a circle is radius squared pi, and the radius here is 6. So 6 squared is 36 pi. I'm gonna leave it in terms of pi since we're talking about a cylinder. Now that's the area, right? That's the area of the base. Now we need to multiply it by the height. Times 20 equals 36 doubled is 2, carry the 1, 72, right? I don't know why I didn't think of that, 72. So this right here is going to be 720 pi, because I did 36 times 2 and then added a 0. So 720 pi feet cubed. Guys, if you do not have your units on this, you will get the problem wrong. I will be checking for that. All right, so for C, the base of a right solid has an area of 50 centimeters cubed. So the area of that, the height is 12 centimeters. Again, to find the volume of anything, we take the area of the base, multiply it by the height, and when we do that, we end up with 600 centimeters cubed. 600 centimeters cubed. Okay, so I think that's it for those problems. Go ahead and give the rest of them a whirl. If you have any questions, let me know. But if you take anything away from today, I want you to take away in your notes, volume equals area of the base times height. We often abbreviate area of the base with a capital B, just FYI. So if you see that, it's different than a lowercase b. All right, have a good one, and I will see you in class. Thanks, guys.